If you're just tuning in, you might be wondering why my talk is titled Terraform, Check Your Source. I'll tell you that I, for one, have never been really great at naming talks. In fact, I was thinking about the name of this talk, and I was thinking, a better name for this talk probably would have been something like Terraform, Trust Your Source, because I think it's a far more realistic expectation. And what that means, I'll dive in this talk, and we'll get to the bottom of it a little later in this talk. But before jumping right in, I want to start off with a fun fact. I don't know how long most of you have been using Terraform, but if you were using Terraform back in July of 2015, there were a total of 15 published Terraform providers. If you were using AWS, the AWS provider, you could just manage a little under 70 resources. If you had attended HashiCorp that year, you were joined with 299 other attendees. And if you were a employee of HashiCorp, you probably had somewhere around 19 colleagues at the time. And I mention all of this because this growth over the past 6 years is very central to this talk. So a bit about myself and the reason that I use 2015 as a frame of reference. This was the year that I dove headfirst into Terraform. I came from a config management background, and so the syntax for Terraform and the idea of managing cloud resources similar in the way that I was used to managing packages and files and services and say something like Puppet seemed amazing. In fact, I thought at the time that cloud provisioning seemed way underserved in a major way, so I hopped on the Terraform bandwagon. In fact, I was so drawn to Terraform that I actually joined HashiCorp, the HashiCorp team as a solutions engineer in 2015 in early July. These days, I work at DoorDash happily, full-time as a compute engineer. I work on the compute infrastructure, mainly Kubernetes. Though my responsibilities don't really end there, I also manage a lot of our infrastructure, a lot of the infrastructure automation, and a lot of Terraform. Today, though, I want to talk about security in Terraform. I want to cover some of the dangers that exist if you try to utilize some of the Terraform modules and providers that may come from untrusted sources. And I want to cover some of the best practices with regards to security if you're going to utilize any code that's being managed by the community. I think that in particular, timing couldn't be more perfect to discuss this topic. If you've been watching the news, you know that supply chain breaches are even more prevalent than ever. So yeah, it's a great time to be talking about this stuff. But before jumping right in, I want to talk about the things I want to cover. First, I want to cover the history of Terraform. I alluded to it a little bit earlier with calling back to 2015. But I want to cover how things have changed over the years, mostly about how those changes have impacted how modules and providers are distributed and managed. I want to talk about how those changes have kind of exposed some new threats, and I want to show you what a few external threats might look like if we're using Terraform. I also want to cover what security practices one should adopt to avoid becoming a victim to those external threats. So let's jump right in. Let's talk about how we got here. I'll try to cover what was happening with regards to modules and providers, but I think I mostly want to talk about providers. I want to put a big asterisk here that a lot of this history is, and the reasoning behind some of the changes that were made is somewhat speculative, but really the important part is that it happened and when it happened, and ultimately what that change led to. So in the beginning, if you were using Terraform sometime between 2015 and 2017, it was a monorepo. It basically, all of the providers lived in the Terraform repo. It lived in the HashiCorp organization. It was really great early on because basically the contributor overlap of folks that were working on Terraform core and the providers was a lot of the same people. In Terraform, it was an open source project, so anyone could contribute to it, but basically, it still is an open source project. But basically, a lot of the folks that were contributing both to the provider ecosystem and the core, the Terraform core, were essentially the same. It was very early on, and so the number of resources and providers in Terraform that was being managed was fairly small. And And if we're talking about modules, modules also existed back then. In fact, the Git source existed back then if you wanted to use a module from version control. But I will say that early on, I noticed that a lot of folks were using local path for their module sources, and they were typically using modules that were in the same repository that they were instantiating the module in. And I can only guess that this is likely because most teams weren't widely sharing their modules to the wider community, but were rather using modules as a mean to just keep their own code dry. And then soon, later on in 2017, providers had to be split out of core. The ecosystem was growing rapidly, and it was this idea of moving the providers out of Terraform core basically had to happen. This was great because the Terraform binary, when resources were being added and new providers were being added and data sources, you were having to cut a release for updating for adding new providers and resources into Terraform, and two, the binary size it was just getting massive since it was all in a single binary. Also, like I was saying, basically releasing new providers had to happen at essentially the same cadence as a Terraform release. So there was no idea of independent core and provider releases. They all happened with the single Terraform release. Providers were eventually split off into this organization called Terraform Providers. You can ignore this screenshot. In fact, it says HashiCorp, but this is what you get if you try to go to the Terraform Providers organization for, say, the Fastly provider. These providers were implemented as plugins in Terraform core, and they would essentially pull down the provider from the Terraform Providers organization. Now that there was a new organization, the maintainers could be added to GitHub, and they could work at a different pace finally than Terraform core. And this meant that the binary size could come down quite a bit. And it was great because most of us that were using Terraform were likely only using 1 to 3 providers anyhow. So it didn't make sense to have a big binary back then. Modules were managed in a similar manner. GitHub organizations began popping up, which made them a little bit more searchable and a bit more widely used outside of one's own organization. And then something really great happened for modules. A module registry was created, and suddenly all of the modules that people were writing were now shareable, easy to discover, and easy to adopt, which saved engineers countless hours. Eventually, talking about providers again, eventually the providers moved from, a lot of the providers moved out of the Terraform Providers organization and moved back to their original individual organizations, in this case Fastly, which was nice because teams could work at their own pace and their own reviewal process. They could assign their own maintainers, and they could figure their own build and test pipelines. And everyone had their own cadence, which was independent of Terraform itself or any other providers. And then something had to happen, but something big happened for providers as well. They got added to the registry, and in Terraform 0.13, the HashiCorp team, or rather the Terraform team, added a required providers block, so you could automatically pull any provider you wanted in that was published to the registry. This made it easy. In fact, HashiCorp made it super easy. They give you this little example over here on how to use a provider where you could literally copy and paste the provider block, and it would pull down a provider when the project initialized. But this made it much easier for you to find and use providers that solved, even the most obscure use cases as well as common use cases. And as we've seen, the provider ecosystem has continued to surge. But of course, with all things, there's a catch. Anytime that you get ease of use, there's always some trade-off. And I like to say the easiest way of describing this trade-off is to look at the FUS triangle, which basically states that moving towards usability or functionality kind of always has this trade-offs. Most notably, if you move something to become more functional or more usable, it's very likely that it's less secure by default. I'll say that this isn't really a hard and fast rule, but there's definitely some truth to this. Now that Terraform made it easy to arbitrarily add providers and pull them in, just from some registry somewhere, there was some level of risk that came with that ease of use. One that wasn't necessarily there early on when all of the providers were basically managed by a set of maintainers that were working on Terraform at HashiCorp. So you might be asking, like, what does that threat look like? And I think the best way to figure that out is, and what's the worst that could happen would be to take a look at a few fictional scenarios here and see what sort of threats are out there. So if you've used Terraform for some time, you're familiar that Terraform has this idea of built-in provisioners like local exec or file. But I call these out because these sort of things can be stuffed into a module, and they can be just tacked along in some resource to execute some arbitrary command. In this case, you could do all sorts of malicious things, right? You could, especially if this Terraform code is executed as a privileged user. For example, we can send an arbitrary post to or post request to Hookbin with a particular environment variable, and as soon as someone executes this Terraform code, well, in this case, it's like really easy spot, right? You can see the curl command there on like 5 lines up, and it says, oh, I'm calling Hookbin, and here's some data that I'm passing. And I try to silence the output so you don't see it happening, but that doesn't do very well because we can see the local exec line. But it really doesn't matter, right? Because even though we could see the output, something already occurred. Something happened. We were aware of it. We didn't prevent anything. In fact, if we look at Hookbin, we can confirm that is the case because we see a fake password that's showing up in the body of the data that we sent over to this endpoint. Now, given that Terraform module registry is readily available for publishing, as an attacker, one could bury this local exec into a module that does something useful. And if you bury this exec somewhere deep enough into the module where it's like in the middle of the DAG or like the graph where plenty of resources rely on it and it relies on plenty of resources above it, it means that it's easy that we can hide this in our output where it's easy to overlook if you're looking at an apply quickly. Additionally, an attacker is able to make this public module more discoverable by publishing it to the registry, and it feels inherently safer since it is in a module registry and it is managed by HashiCorp, the registry that is. They could even go an extra mile by pumping their download numbers and making it look like it got a lot of downloads. Now, obviously, provisioners in a module is a fairly trivial example, and you could probably detect it by doing some quick grepping in the code base, just because you know what to look for, local exec and file provisioners, or just a provisioner block, right? And we saw that the request was clearly visible, and in all likelihood, there's a high likelihood that your org might be writing their own modules already. So let's talk about a bit harder to detect scenario. And I want to talk specifically about providers. For those who aren't familiar, a provider is just a static binary written in Golang with the intended purpose of making API calls and performing CRUD operations that represent the state of a resource or data source in Terraform. But at their very core, they are binaries that can literally do anything. In this case, we're looking at the Terraform random provider. And if we were to look at one of the functions, the create pet function that creates a random pet name normally, we see that that's what this mostly does. It creates a random pet name, and then it sets the ID to that pet name, and then and gives it back to Terraform as the ID that Terraform could then use. But as you can see, as an attacker, I could easily implement some malicious code in this function, right? I can do essentially the same thing that I did in the module example where I make a request to Postman and I take some secret pass from the environment and I post it to that URL that I was used in the previous example. And then as you can see, I also intentionally didn't output anything here. So there's no, even if an error happens, it won't surface. And now with a widely available registry for providers as well, as an attacker, you could take advantage of a registry to publish this bad provider. In fact, like we pointed out earlier, it gives users an easy provider block just to use in Terraform. And when the Terraform CLI runs, it pulls down the infected provider, and then it initializes in that working directory, and that's it. Now, I will say that there are a few requirements to getting this in the registry. One, you need a GitHub repo. Two, you need to sign your release. You need to publish checksums. But these are not things that prevent an attacker from publishing, right? Anyone can do those things. And then again, when we execute that provider, after we use the provider block example that was given in the registry, this is what we see. It looks like absolutely nothing has happened here. It created a random pet, and it spit out the pet name. Not once did we see it making a request to request bin. Instead, it just is only surfacing resources, their arguments, their attributes, not any actual API calls or arbitrary requests that may be occurring, because that would be far too verbose for a Terraform run. And it also is worth pointing out that this isn't exclusive to applies. You could also make this happen every plan. All you would need to do is stuff this same malicious code into a read operation, and it would occur during the plan phase. And once again, we can see that the request was made. In fact, it sent over a secret. And there we go. We have a secret from the user's environment by just a simple Terraform execution, and they are unaware of it. But let's imagine how bad this could actually get, right? Imagine that instead of just an environment variable, these were credentials. Maybe they're AWS credentials, and maybe there is some sort of automation on the other end to create an IAM user or an assumable role for more permanent access to your entire cloud infrastructure. It's not unheard of for Terraform to have this level of access, because its job is to manage all of your cloud resources. Additionally, as I mentioned, most organizations, they probably won't think twice about using an existing provider. In fact, in my opinion, I would take a gamble that most organizations would more readily use available providers out there than trying to manage or build it themselves. If you were, counter to the example that we saw in modules, where it's much more likely that someone's probably going to write their own module. Also, there are other ways of getting this thing further distributed, right? An attacker could use a combo style attack, where they take their bad provider and they find a module that's widely used in the ecosystem, like in this case, the Lambda module that has thousands of downloads. And maybe they open a PR against this module repo and say, find an unsuspecting module owner, in this case saying hey, there's this name collision. If we see the name prefix here, we need to add some sort of random pet name to avoid this collision. And maybe you can get them to accept your contribution. And if you could, anyone who uses the latest version of that modified module now gets the provider with the malicious code embedded in it. So it is possible to use the Terraform module registry and the Terraform provider registry and detect these sort of threats. So let's talk about that. And let's talk about how we would prevent these things. I do want to mention that some of the preventative measures that I'm going to point out here might be AWS specific and may assume Terraform's running in some sort of automated way in your VPC, but the approach is pretty much the same. But it might not be applicable if you don't control where Terraform runs. So if that's the case, your options might be a little bit more limited. First, I'll say, do your due diligence, right? The easiest solution is probably just sticking with verified or official providers, because basically when you do this, you're getting Terraform in the way that it was in 2015, 2017 years, where basically all of the providers are essentially managed by HashiCorp or have been pre-approved through some sort of verified partner program with HashiCorp. So the risk is significantly lower. They undergo a level of scrutiny and guarantee for the quality of these providers in order for them to get published, just like you would expect back in the early days of Terraform. If you want to learn more about these tiers, you can find them in the Terraform provider documentation. Okay, and then part of your due diligence, you probably want to be performing some static analysis. You want to be pulling down your provider source code. You want to be doing things like running GoSec to perform an in-depth analysis of maybe some vulnerabilities that might exist in that provider. It won't surface things like intentional HTTP calls. I can show you that on the next slide, but if you want to find, you can often just do a simple grep for URLs and to see what URLs are in the code base and what calls it's making. Obviously, this could be obfuscated or encoded, so it's not 100% a guarantee that's going to surface anything. But I'll say once you have got a chance to go through all of the code, And it's important to also, build from source and then check the MD5 sum of the binary that you just built, and then compare it to what's published or what's released under the same tag. Also, if you're taking a look at the provider source code itself, you need to be chasing down the Go modules as well. But I'll get back to that here in a second. So I just wanted to show you this, which is basically a linter that services a set of particular issues. It runs GoSec and a number of other things. But as we can see, that it actually found the HTTP post in this case, but only because it doesn't have a return value. So that's why we see it here. But if you wanted to, you could write your own linter that specifically looks for HTTP requests or URLs. Okay, so I was talking about modules earlier, Go modules, and I looked at almost all of the providers published in the Terraform provider registry, and I found at least 400 independent GitHub repos that are being referenced one way or another. You're going to want to chase these things down too, because these dependencies are also a rabbit hole, and it's a part of your supply chain, and it's a valid inspection point. Because, for instance, I found this dependency in a really widely used provider. It's a fairly simple example, so maybe not the best example because there's not a whole lot of lines of code here. But as you can see, the point here is a lot of these dependencies are going unmaintained. This one hasn't been updated in 3 years. And it's very likely that the author is just sort of letting this repository fly under the radar. And they're more than willing to make you a maintainer if you're looking to fix, better, or contribute to their aging repo. And malicious code could also be injected here and find its way into our Terraform provider. But I want to say perhaps my favorite way of uncovering what the provider is doing is just doing a test and observe method, where I like to stand up a sandbox environment and use a firewall like Little Snitch or Open Snitch to uncover outbound connections. So with network filtering on, Little Snitch basically will report on outbound connection attempts, good and bad, and block the request by default and ask for an approval. So if we look at this particular example, we can see a request has been blocked. It's going to Hookbin. Our random provider probably shouldn't be doing that. Also, I forgot to call out, if you on OS X, you can also use Lulu. It's a great option to Open Snitch and Little Snitch, and it's free. But yeah, so like this is not something we want to see. We don't want to see our provider making a call to some arbitrary URL that we are unaware of. And just a heads up, another worth calling out is that there's previously been reported ways to bypass firewalls now that they use these network extensions rather than network kernel extensions, which Apple deprecated. It's been reported that some Apple apps, for instance, have figured out ways that are bypassing network extensions. So just keep that in mind, that like an attacker could get clever and maybe even bypass Open Snitch or Little Snitch in this case. And then, as we can see, Terraform providers attempting to make a request to a third party that we didn't expect, and this is a huge red flag. So if you ever see anything, report it to HashiCorp. Another possibility is just doing simple egress filtering. This can be done in a number of ways, but you can use security groups or NACLs to allow outbound to predefined IP addresses. But I'll say that this is not scalable, and it's going to be hard to keep track of your IPs, and that may be subject to change. Also, this example is terrible because the egress block literally allows everything to the internet. But I just want to show what a Terraform resource would look like if you were trying to like add an egress rule for a security group. Also kind of assumes that Terraform itself is running in VPC and it has a security group applied to it. So just keep that in mind. This is how it would look as a NACL. This may work if you're in very slim use cases. This might work if your worker's internal. Say you've downloaded all of your providers that you're using. You've allow listed your VCS provider. You've added the IP addresses to the egress rules here, and then you use like a VPC endpoint for S3 state bucket access to keep all of that traffic internal. There are a number of FQDN egress filtering services out there. So you could filter based on host names, but you're going to have to keep track of this as well. And it's easier than managing the IP addresses, but you're still likely to have bring on a team to manage this additional component. Some good examples of this would be like Aviatrix or AWS Network Firewall that allow you to perform web filtering and stop traffic to bad URLs. In the example, the bad provider would call out to Hookbin, and we could have blocked that entirely. But perhaps my what I think is the most reasonable solution would be relying on predefined policies. And a good solution like CompTest, you should use something like CompTest to do this. And if you haven't heard my talk from HashiTalks 2020, you should check it out. But I share a bit about what CompTest is and how it works with some simple examples. CompTest is and OPA are my new favorite hammer. It'll be I would be doing injustice if I didn't call it HashiCorp, who has a similar policy framework called Sentinel. But basically, CompTest allows us to write tests in Rego against any of the configuration data it supports. And it just so happens that it supports HCL and HCL2, which means it's a great tool for inspecting our Terraform code against some predefined policies in an automated way. And it will spit out a exit code, either 0 or non-zero, and a message if the policy is violated. So let's take a look at one of these policies. So here's a really simple one. We could create a provider allow list of some providers that we've trusted, that we've done some due diligence on. We could check for any violations. We can see all the required providers used in the config, and we could see if it's not in the allow list. If it's not, then we throw an error and say, deny, this provider is not pre-approved. There's been a provider violation. OPA also supports glob matching if you wanted to allow list an entire org. So you wouldn't have to do like every single provider if you trusted an entire org, if you wanted to use glob matching instead. And if we ran CompTest using the code that I showed you in the last example, with the Terraform providers that I catted out at the top here, the fake provider, Weekend Ops, and the HashiCorp AWS, we see that CompTest throws an error saying that 2 providers violate the policy that we defined in the last example. And then it throws a non-zero exit code. So this would be a great step in your pipeline before initializing Terraform. So it would never even pull in those bad providers because you failed the policy. You could also do something similar in Sentinel. Here's what it looked like written in Sentinel. Basically, you have your allow list, you have all the providers, you look up all the providers, you check for any violations, and then as long as it's 0, you're okay. But if it's not, then the policy has been violated. Note that I am using a lot of helper functions here, which I linked in the comment above. So you should check that out because HashiCorp's done like an amazing job at writing some of these helper functions and giving you some examples in that Terraform guide repository. And then here's one that you could use to prevent local file or local exec provisioners, which we saw in our first example with the module. These policies are great, both Sentinel and OPA, because they allow us to prevent using code from untrusted sources, untrusted modules, using provisioners that we don't want to use before it ever happens. So like this is the step that you could put in place to ensure that your pipeline or whatever the process is doesn't proceed if it violates any of the predefined rules that we've configured. Now, one thing worth calling out, Providers now has provider locks. It's available now in Terraform 14. But essentially, basically what this is it ties your providers with some known good hashes that you can check into version control. And as far as I know, basically this helps just guarantee the provider's integrity and that it actually is the provider that we think it is. So it won't actually, I don't think it actually prevents you from pulling in external providers, but I could be wrong. So to recap, we talked about several things. We talked about performing proper due diligence, about how you should probably determine what providers you trust, and we could do static analysis to determine what those providers are and find things that look off to us. We talked about how we could determine what a provider is doing through some sort of controlled testing environment. In the case, I used Little Snitch to show you some of the outbound connections that the corrupt provider was trying to make. And then we talked about defining policies to protect against potential threats using egress filtering or policies that allow less trusted sources and provisioners before our project ever gets initialized. It is important to note that these aren't mutually exclusive. You should probably be using some, if not all of these approaches. In fact, I hope the one takeaway is that you at least adopt one of these practices, but that's obviously up to you. Parting fact, I wanted to share one parting fact. There's almost 600 uniquely named providers now compared to whatever it was in the teens that I talked about, 15 providers, right? And likely all of these providers have their own dependencies. I would love for someone to graph this. I just didn't have enough time to put a graph together, but I'd love to see what that graph looks like. And the adoption of Terraform and the growth of the community has been obviously an amazing thing to see. And I'm not suggesting that you shouldn't use the Terraform registry. In fact, quite the opposite. I think you should be contributing it and making sure that the code quality stays high and that we're solving real use cases for the wider community. I'm just advocating for folks that are using providers in the registry, practice a zero trust first model, and figure out what is their thing doing and whether or not they trust it. So be safe out there. And as always, if you see something suspicious, report it. Thanks again for letting me share with you for Hashi Talks 2021. If you want to chat more, you can find me on Twitter as Moot Point or more actively on Clubhouse as JCW. We're hiring infrastructure folks at DoorDash in cloud engineering and security. So if you're interested, you can also reach me on LinkedIn.